In this video, I'll discuss finding the sine and cosine of an angle that's in standard position, like the one in this diagram, when you're just given a point on its terminal side. When you have an angle in standard position, like this angle theta, the only thing you need to define the angle is a point on the terminal side of the angle. In this case, that point is -8 for the x-coordinate and the square root of 17 for the y-coordinate. This is enough information to find the sine and cosine of angle theta, provided you know the sine and cosine ratios. The sine ratio in this context is that it says that the sine of any angle theta is equal to y over r, where y represents the y-coordinate of any point on the terminal side of the angle, and r represents the distance from the origin to the point. In this diagram, the value of r isn't given, and actually the hardest part of this problem will just be to find this value of r. The cosine ratio is x over r. The cosine of this angle theta can be described as x over r, where x is the x-coordinate of any point on the terminal side, and r, again, is the distance from the origin to that point. Let's begin finding the sine and cosine of this angle. So again, in this problem, really boils down to just finding the value of r. I know that x is -8. I know that y is the square root of 17. The sine and cosine ratios both include the value of r. Once I know r, I can state those two ratios. The value of x, again, -8. The value of y, the square root of 17. And the value of r is the last piece of the puzzle to state the sine and cosine ratios. There's actually a couple ways to find this value of r, which is actually a distance from the origin to the point -8 square root of 17. I could use the distance formula and compute the distance from 0, 0 to -8 square root of 17. Or I could represent the situation as a right triangle. And in this right triangle, the hypotenuse is the value of r. The bottom of the right triangle, the distance from the origin to the left to the vertex of the right triangle, the vertex of the right angle, is 8 units. And from the vertex of the right angle up to the point on the terminal side of the angle is the square root of 17. So here I have a right triangle where one of the legs is 8 and one of the legs is the square root of 17. I can use the Pythagorean theorem to find the value of r. And I believe that's the easiest way to find r in this case. The Pythagorean theorem, I'll call it x squared plus y squared equals r squared. X squared plus y squared equals the hypotenuse r squared. I'll substitute an 8 for x and a square root of 17 for y. Now in this problem, x is actually -8, but because I'm squaring it, 8 squared is going to be 64, just like -8 squared. And the square root of 17 squared is just 17. A square root and a square are inverse operations. The sum, 64 and 17, is 81. And so I have 81 equals r squared. I'm one step away from finding the value of r. I can just take the square root of both sides. When I introduce a square root into this equation, I do not have to include a plus or minus in front of the square root of 81 because r is representing a distance, a positive distance. The value of r will always be positive in these situations. The square root of 81 is, of course, 9, and the square root of r squared is r. So we have the value of r. It is 9 units. r is 9 units. Once you know r, we were given x and y, we can now state the sine and cosine ratios. First, the sine ratio. Again, the sine is y over r, so the sine will be the square root of 17 over 9. Sometimes when stating a sine or a cosine ratio using this method, there will be a reduction required at the end. Perhaps you'll have to rationalize the denominator, but the square root of 17 over 9, although an irrational number, is simplified. Cosine, x over r, will be -8 over 9. Usually you'll see that negative sign written in front of the entire fraction instead of just written in front of the 8 in the numerator. Again, like the sign, negative 8/9 is reduced. Sometimes you'll have to reduce it, but in this case, the value that we got for r and the value we were given for x, written as a fraction, are already in lowest terms. The cosine is negative 8/9. So the final answer to our question, find the value of sine and cosine for the angle in standard position, whose point on terminal ray is negative 8 square root of 17. The sine of the angle is the square root of 17 over 9, and the cosine of the angle is negative 8/9.